This is a Leaving Cert mathematics question on complex numbers. It's from paper 1 from 2017. It's worth 25 marks, so it's a short question. And for 25 marks, it should take you about 12 and a half minutes in the exam to do. Of course, if you're practicing, it may take longer. Right, the first part, question 2, part A. The complex number Z1 equals A plus BI, where I squared is minus 1, is shown in the Argand diagram below. Now, I squared is minus 1, that's what helps define this as a complex number. You have your real part, which is A, and the imaginary part, which is B. So, it says write down the value of A and B. Okay, so the value of A, that corresponds to the real part, and the value of B corresponds to the imaginary part. If you look at the Argand diagram, the horizontal axis is labelled RE, short for real, and the vertical axis is labelled IM, short for imaginary. The origin is here, 0. Okay, so this is the complex number here. It is called Z1, and we look at the coordinates of it. It's a bit like coordinate geometry, you know. On the horizontal axis, which is now called the real axis, it has a value of 3, and then on the vertical axis along here it has a value of minus 1. If you were doing coordinate geometry, you would say that's 3 minus 1. Okay, but we won't do it like that now because we're working with complex numbers. But it's basically 3 on the horizontal axis, which is now the real axis, and 1 below 0 minus 1 on the imaginary axis. So we put in for A 3, and for B we put in minus 1. So Z1 is equal to 3 minus 1i, or 3 minus I. Now, you don't need to write this part. This is what you need, the A and the B. There's 5 marks for this question. Okay, 5 marks. 5 marks to get it totally right. If you get one of these right and one wrong, you'll get 2 marks. And if you get them both right but the wrong way round, you get 2 marks. So really your range is 0, 2, or 5 marks. That's that part done. Now the next part is Z2, part 2, is equal to 1 minus 1 plus 2i, and you have to plot a Z2 on this Argand diagram here. So if you look at it, it's minus 1 is the real part. That means it's going to be, you're looking at minus 1 on the horizontal axis, the real axis. So here it is, minus 1. 1 left of 0. And it's plus 2i, that means it's 2 above 0 here. 2 up the imaginary axis. So this is your point here. So you would plot the point, but you also must label it Z2. Okay, to get full marks. To do that correctly, that's 5 marks. You only get 5 marks. You can only get 0 or 5. It's either right or not right. Okay then, the next part, part C, or part 3, question 2A, part 3, it says Z3 is equal to Z1 divided by Z2. Write the Z3 in the form x plus yi, where x and y are real. Basically, you have to write it as a complex number with a real part and an imaginary part. Okay, so I'll do this not on the squared paper. Alright. So here we have it. Okay, so Z3 is equal to Z1 divided by Z2. Now we already found a Z1 was equal to 3 minus I. That was the one that was plotted on the Argand diagram. And they gave us a Z2, which was minus 1 plus 2i. So, there are 10 marks going for this question. If you write down a Z3 is equal to Z1, 3 minus I, divided by a Z2, minus 1 plus 2i. We have that equals a bit lower. To actually do this, to substitute in either Z1 or Z2 into this equation correctly is worth 4 marks. The whole question is worth 10 marks. Right? Now the important thing about doing a complex number division is that you use a complex conjugate. So you have to identify the complex conjugate. it is the number that when multiplied by the bottom part can make the bottom part of this division real. So the complex conjugate has to be the complex conjugate of minus 1 plus 2i. And that is going to be minus 1 minus 2i. Because all the complex conjugate does is changes the sign of the imaginary part. From, in this case it's a plus, so now it's changed to a minus. And we multiply above and below the line by minus 1 minus 2i. So now effectively we're going to multiply the 3 minus I by the minus 1 minus 2i, and the minus 1 plus 2i is going to be multiplied by the minus 1 minus 2i. Right, so I'll call this the bottom and the top, and I'll do the bottom part first because it's easier and quicker. So basically, actually, to get that far, you'll get 6 marks. Okay, to get that far, that's worth 6 marks. Right, so the bottom part is equal to minus 1 plus 2i multiplied by minus 1 minus 2i. Now if you've done many multiplied many complex numbers by their conjugate, you'll come to the shorthand way of saying, well, that's the same as 1 squared plus 2 squared, which is equal to 1 plus 4, which is 5. And now I'll do the top part. Do that over a bit, top. Now there's no getting away from the top part, you have to multiply it out. There's no shortcuts in this one. So it's a 3 minus I is going to be multiplied by the minus 1 minus 2i. So we'll split this first bracket after the 3 and before the minus I, and that will become 3 on the second bracket, minus 1 minus 2i, then minus I on the second bracket, minus 1 minus 2i. And make sure you've got your signs right and you've got your i's clearly identified so you don't mix them up with ones. Right, so now I'll multiply this out. 3 times minus 1 is minus 3. 3 2's are 6. I, and it's a plus by a minus, so it's going to be minus. Then the next part is minus I multiplied by minus 1. So minus multiplied by minus is plus. I times 1 is I. And now minus multiplied by minus is plus. I times I is I squared, and it's multiplied by 2, so it's going to be 2i squared. Right. So this is the top part. And it always happens in the top part that you're going to have an I squared. When you're multiplying two complete complex numbers, you're going to have an I squared part in it, and you'll have two terms that have an I in them. Okay, so we've multiplied out. This here was multiplication rules for integers, and now we're using the addition rules for integers. Addition rules. Okay, so we add together the real parts and the imaginary parts. So, but before we have to sort out this bit here, right? Now the quickest way to do this is I squared is equal to minus 1, which will effectively change the sign of its coefficients. So we'll have minus 3 minus 6i plus I, and that becomes minus 2. So you drop the I squared and you change the sign. Now that means this is real, the minus 3 is real, and the minus 2 is real. We add these together and we'll get minus 5. And then we have the minus 6i and the plus I, which will give us minus 5i. So that's what the top is equal to. Okay? Now, just leave this up a little bit. All I have to do now is write out a Z3 is equal to the top part, which is minus 5 minus 5i, divided by the bottom, which is 5. Now, to get that far there, having done all the multiplication out correctly to there, it's worth 8 marks. Now here you're not going to get the full marks unless you separate this here into its real component and its imaginary component. So that will be minus 5 over 5, that's that 5 over that 5, and then minus 5i over 5. But now you can see 5 goes into 5 once, so finally you will have Z3 is equal to minus 1 minus I. And that's the answer. That's for question 2A, part 3. Now then, the last part of this is question 2B. And 2B is worth 5 marks. Right, here it is here. You have to solve for z. When 2z minus 6 on brackets 4 minus 6i is equal to brackets minus 1 plus I multiplied by 4 minus 2i. Now this part is worth 5 marks. And you can get 0, 2, 3 or 5, depending on how far you get through. Now, so the first thing, you treat it more or less like an algebra question. And in the end you'll have a z one side of the equals and everything else the other side of the equals. So the first thing I'm going to do is I'm going to multiply out this bracket here. The 6 on the 4 minus 6i. So I leave the 2z, 2 times a z. Then a minus times a plus is going to be minus. 6 4s are 24. Right? And then I have a minus times a minus will be plus. 6 6s are 36i. Now keep the equals. So I could actually draw a line down here that will ensure I keep the equals there so I don't lose myself. Right, actually, to do that much, to do one correct multiplication, you will have gained 2 marks. Right? So now the next, so 2 marks at that place. 2 marks at that stage. The next thing is to split up the brackets, and you have minus 1 on the second bracket, 4 minus 2i, and then plus I on the second bracket, 4 minus 2i. So we'll leave this as it stands, so I'll just rewrite it down to a z minus 24 plus 6i. Now I can't add 36i. I can't add the 36 or the 24 together because this is an imaginary term, it's got an I, and this is a real term, so you can't add them together. And this is on a z, so you don't know what that is yet. Equals. So multiply this out. 1 times 4 is 4, but it's a minus 1, so it's minus 4. Minus times a minus is plus 2i, and then plus I times 4 is 4i, and then I times minus 2 is going to be minus 2i squared. Right. Now I can tidy up the right hand side a bit, leave the minus 4 for now. The 2i and the 4i, I can add these two together because they're imaginary, plus 6i. And now I'm going to drop the I squared, which is equivalent to minus 1, so I change the sign of the minus 2 to a plus 2. So I can tidy that. Minus 4 plus 2 is minus 2 plus 6i. And that's equal to 2z minus 24 plus 36i. Now I'm just going to do a quick way of, I want to leave the 2z here. So the 24 is going to go across to the other side of the equals, and so is the 36i. Now, this is a minus 24, so when it goes across the equals, it's a plus 24. This is just a quick way of doing this, right? So 2z is going to equal minus 2 plus 6i. Bring the minus 24 over, it becomes plus 24. Bring the plus 36i over, across the equals, and becomes minus 36i. Nearly finished now. Okay, so now I've just got 2z equals. The real part is the minus 2 and the plus 24, which will give me 22. And I have a plus 6i and minus 36i, and that will give me minus 30i. Now that's 2z, and I just want 1z. So I have to divide a z by the thing it's multiplied by, which is 2. So I'm just going to divide by 2, divide by 2, divide by 2. I have to divide every term in the equation by 2, so it still balances. So that will be then 2 into 2 equals once, and I'm left with z equals 2 into 22 equals 11, minus 2 into 30, 15i. And that's the whole question complete. Thank you.